मर्ज हो जाता है. चलो, let's continue. Now, look at the first one over there. First complex क्या है people? FeCO5. Give me the charge on Fe over here. 0. Why? Because carbonyl is a neutral monodendric. Pay attention, I will give you all the time to copy. So, charge on Fe is 0. Fe atomic number please?
26.
Excellent, 26. Electronic configuration? 3d6, 4. Excellent. 3d6. And यहाँ पे there are 2 electrons in 4s. Now pay attention. If there are electrons in 4s, move them to 3d. समझ में आ रहा है? In all the previous examples that we did, 4s was empty. But over here, if there are electrons in, we move them to 3d. समझ में आया? बोलो रे. चलो, so move करो. And what is CO? Strong field or weak field? So also what will happen? Pairing will take place. So pay attention. सबसे पहले हम क्या करते हैं? Pairing due to the presence of strong field ligand. So how many electrons are there? 1, 2, 3, 4, 5 and 6. आगे हम क्या करेंगे अभी? There are electrons present in 4s. क्या लिखा था? If electrons are present in 4s orbital, move them to 3d. चलो मूव कर दो. क्या मिलता है हमें? And these electrons I have moved them over here. Did you get that? Now, how many lone pairs are coming in?
5.
उनको accommodate करने के लिए we have 4s, 4p and 4d. How many lone pairs are there? 5, because the coordination number here is 5. Where did these electrons come from? Electrons from carbonyl. So, what is the hybridization over here? What is the hybridization over here? sp3d. Can we use this empty wala? If we start here, तो क्या मिलेगा hybridization? dsp3. And you can also use sp3d. But over here, geometry क्या हो जाएगा people? ये जो 2 electrons यहाँ है, we could have also adjusted them over here. तो hybridization क्या लिखेंगे? dsp3. This would change to, वो मैं लिख नहीं रहा हूँ electrons from ligand, वो आप लिख दो. This is very specific for FeCO5. Now give me the geometry. There are 5 of these. तो कैसे दिखेगा ये? Sorry, pardon me. It's not square pyramidal. Now give me the geometry. Trigonal, pyramidal. Number of unpaired and magnetic moment. In any example, if you have electrons present in 4s, we'll be moving them to. और ये first 3 examples वैसे हैं. They're going to have electrons in 4s, which we have to move to 3D. Let's take the second example. Second example क्या है वहाँ पे? जल्दी जल्दी. Give me the second example, people. CrCO6. Quickly give me the charge on chromium over here. 0, because carbonyl is a neutral monodentate. Jaldi jaldi chromium electronic configuration, please. 24. Argon 3d5 4s1. Is CO a strong field ligand or a weak field ligand? तो directly लिख रहा हूँ पे. Since CO is, what will happen? Pairing takes place. थोड़ा shortcut में लिख रहे हैं, save time. So 1, 2, 3, 4, 5. There is electron in 4s. Since there is electron in 4s, electrons are present in 4s. क्या करेंगे हम? Move them to 3D. Move किया, क्या मिलता है configuration of 3D का? This is 3D. This electron is now here. How many lone pairs do we have to accommodate? 6. Where will I start from? क्या लिखेंगे हम यहाँ पे? Electrons from ligands. Quick hybridization. Geometry. Magnetic moment, because number of unpaired. Inner, outer. Low spin, high spin. ठीक है, समझा? Anyone did not get that? The third one I expect आप लोग करना. ठीक है, चलो अभी भी कर लेते हैं. Let's do it. यहाँ से quickly give me the charge on Mn plus 1. Yes or no? Give me the electronic configuration of manganese. 3d5 4s2. That is Mn. Mn plus का electronic configuration 3d5 4s1. 3d5 Cn is a Cn is a strong field. Cn is a strong field ligand, and hence pairing takes place. सेम ही आने वाला है वो, अगर समझो तो. Getting that? If you just replace this part by वो Mn NH3A, all of this is the same. कर सकता है. For the third and similarly for the fourth one, which complex is that? The fourth complex, brown ring. What's the charge on Fe over there? +1. So if Fe is +1, what will the electronic configuration be? 4s1 3d6. समझ में आया? Yes or no? 4s1 को कहाँ शिफ्ट करना? 3d में. But what is water? So समझा? Yes or no? But ऐसा भी क्वेश्चन होना चाहिए. But there is still NO. But how many H2Os are there? Majority of the ligand present are WFLs. कर सकता है वो फर्स्ट 4? बोलो रे. ठीक है? नहीं किया तो वैसे मुझे बता देना. Next, let's do the 5th, 6th, 7th वाला. पॉज कर देना. पॉज. चलो. Now give me the fifth question. क्या है people? Mn NH3 6 2 plus. ठीक है. Give me Mn पे charge over here please. +2. Quickly give me the electronic configuration of Mn +2. Mn +2 is argon 3d5 4s0. Next step, what do we do? NH3 is a, and hence this should have happened, but NH3 or Mn plus NH3 behaves as a weak field ligand whenever we have Mn +2 and Fe +2. वो I think second example है, or sixth example. So if I have Mn +2 and Fe +2, NH3 behaves as a weak field ligand. समझा? ठीक है. Go back. Okay. Now, we'll quickly give me the hybridization over here, people. Where will I accommodate these electrons? (4s, 4p and 4d. So how many lone pairs do I have to accommodate? 6. Electrons from? I'm sorry, electrons from? Ligand. Hybridization, please. sp3d to geometry octahedral. Magnetic moment root of 5 into 5 plus 2, that is root 35. High spin, low spin,
High spin.
high spin.
Outer.
Outer, inner.
Outer.
Sixth वाला कर सकता है. There will again be no pairing, even though there is presence of a strong field ligand. You will get that now. What is the seventh question? CO H2O6 3 plus. Can someone guess the exception? CO H2O6 3 plus. Guess the exception for me. Even though H2O is a weak field ligand, but it behaves as a strong field and pairing takes place. Samjha? The reason is exactly the same for the previous. H2O behaves as strong field ligand for CO3 plus and pairing takes place. समझा? क्या बात है. चलो जल्दी जल्दी. Charge on cobalt +3 cobalt +3. What is the electronic configuration? Argon. Excellent. 4s0 3d6. Very nice. चलो. Oh, sorry. Pairing takes place, तो directly बना रहा हूँ मैं. आगे का कर सकते हैं हम. How many lone pairs?
6.
Hybridization. D2. Geometry. Octahedral. Magnetic moment. Low spin complex. Inner outer. Samjha? Yes or no? Any questions still here? Please write down. We'll start by writing limitations of VBT. Limitations, drawbacks of VBT. First point. It couldn't explain why in many cases extra pairing takes place. Extra pairing takes place. That is low spin complexes. And how are they stabilized? stabilize. Bracket में couldn't explain strong field ligand, weak field ligand. Couldn't explain strong field ligand, weak field ligand. Next point. Couldn't explain the spectrum of coordination compounds. Couldn't explain the spectrum of coordination compounds. Couldn't explain the spectrum of coordination compounds. Third, couldn't explain colors. Couldn't explain colors. In transition metal complexes. In transition metal complexes. Next point.
In transition.
Metal complexes. Next point. Does not give quantitative interpretation of magnetic data. Quantitative interpretation of magnetic data. Interpretation of magnetic data. Why in case of SFLs, the theoretical magnetic data was different and the experimental magnetic data was different, all that. CFT, okay, now writing theory, crystal field theory.
So the reason DD transition is different than CFT.
So you have to explain that. CFT is an electrostatic model. CFT is an electrostatic model which considers metal ligand bond. Metal ligand bond to be arising purely from the electrostatic interaction between metal and ligand. Electrostatic attraction between metal and ligand. Next point. Ligands are treated as point dipoles. Bracket point negative charge. And central metal atom is treated as point positive charge. Point positive charge. Next point. Repulsion between electrons. Repulsion between electrons in d orbital of metal. In d orbital of metal and ligands between, repulsion between electrons in d orbital of metal and ligands play an important role in deciding the geometry and stability. Geometry and stability. Next point. In octahedral complexes. Ligands approach the central metal atom along the axis. And hence electrons present in the EG orbital, bracket में write down. Which are the EG orbitals, people? dx square minus y square and dz square. Electrons present in the EG orbital experience greater repulsion as compared to T2G. So, which are the T2G orbitals? dxy, dyz, dxz. So, EG orbitals acquire greater energy as compared to T2G. So, EG orbitals acquire greater energy as compared to T2G. And d orbital loses its degeneracy. Next point. Some ligands are able to produce strong field. Fields, in which case DD splitting will be large. PD splitting will be large. Whereas other produce weak field where splitting of the d orbital is small. Where splitting of the d orbital is small. In general, ligands can be arranged in a series. In general, ligands can be arranged in a series in increasing order of field strength. Ligands can be arranged in a series in increasing order of field strength. Field strength as shown below. This series is called as spectrochemical series. Spectrochemical series. Copy the series, people. सार्थक एक मिनट बैक कर दे. Next point. Continue. Let's continue, people. Next. Did we write this crystal field splitting energy depends upon the field produced by the ligand and the charge? Next point, right? Crystal field splitting energy. Crystal field splitting energy. Bracket में people. Octahedral energy delta naught. Crystal field splitting energy delta naught depends upon the field produced by the ligand. Depends upon the field produced by the ligand and the charge on the metal ion. The charge on the metal ion. In D1 D2, D3 configurations in D1, D2, D3 configurations. Electrons occupy T2G orbital. Electrons occupy T2G orbital. Electrons occupy T2G orbital in accordance to Hund's rule. Hund's rule. In accordance to Hund's rule. However, for D4 configuration, two possible patterns arise. Two possible patterns arise. Subpoint. Two possible patterns arise. If delta naught is less than P. What does this capital P stand for? Pairing energy. If delta naught is less than P, pairing energy, the fourth electron enters one of the EG orbitals giving rise to the configuration configuration is on the board, giving rise to the configuration the ligands for which, part of the same point, the ligands for which delta naught is less than P, delta naught less than P are known as WFLs. What do you mean by WFL, people? Weak field ligands are known as WFLs and form high spin complexes Next subpoint, if delta naught greater than P, it becomes more favorable for the fourth electron, it becomes more energetically favorable for the fourth electron to occupy what, people? T2G. To occupy T2G with the configuration. What will the configuration be this time? T2G4 Eg 0. And the ligands for which delta naught is greater than P are known as, क्या बोलेंगे people? SFL, strong field ligands. And what do they form, people? Low spin complexes. And they form low spin complexes. Last point in octahedral complexes. In case if last point, yes, next point. In case if metal belongs to 4D and 5D series, 4D and 5D series, then all ligands behave as SFLs. What's the reason वहाँ पे? Because pairing energy becomes higher than the octahedral energy. So over here, people, whether this is fluorine or amine, will pairing takes place or no pairing? Pairing will take place because all ligands behave as strong field ligands and all of them will form low spin complexes. तो इनको भी solve करके लाना. And you will give me what is the hybridization for all of them. You will find the hybridization geometry. Remember, rhodium, iridium, 4D 5D, irrespective of, क्या बोला है, 4D 5D series, irrespective of the ligand present, और सबके सब ligands behave as strong field ligand. Pairing तीनों में करना. Did you people get that? Yes or no? क्या बात है. Start किया है अभी. So this was CFSC in octahedral complexes. Please write down. Crystal field splitting in tetrahedral complexes. Crystal field splitting in tetrahedral complexes. I'll check the notebook सबका tomorrow. I want all this complete by tomorrow. I'm sorry. In tetrahedral complexes.
booklet में doubts.
I'm sorry.
Booklet में doubts.
Oh. Yes. First point. Okay. पाटिल को बताओ रे लिखना क्या है? Crystal field splitting in tetrahedral complexes या tetrahedral coordination entities. First point. In tetrahedral complexes, d orbital splitting is inverted as compared to octahedral field splitting. What does that mean, people? Pay attention, please. In octahedral complexes, ligands approach the central metal atom. कहाँ से? Along the axis. In tetrahedral complexes, ligands are approaching the central metal atom in between the axis. तो किसका एनर्जी ज्यादा है अभी? No, it was along the axis in octahedral, but in tetrahedral,
In between.
the approach is in between the axis. Since the approach is in between the axis, which orbitals lie in between? T2G. And किसका एनर्जी शूट अप हो जाता है? T2G. और किसका एनर्जी कम है this time? That's why the first point. First point क्या बोलता है? In tetrahedral complexes, d orbital splitting is inverted. Did you people get that? Anyone did not get that? Ligands approach. Next point. Ligands approach the central metal atom. Ligands approach the central metal atom along the axis. Sorry. In between the axis. In between the axis. Nice save. In between the axis. And hence who has higher energy? Say to back up T2G higher energy, EG lower energy.
T2 and
EG lower energy. Next point. There are only 4 ligands. There are only 4 ligands instead of 6. There are only 4 ligands instead of 6. Hence, the ligand field, hence the ligand field is 2/3 the size. Ligand field is 2/3 the size, and the ligand field splitting is also 2/3. Ligand field splitting is also 2/3. And hence relation between tetrahedral energy and octahedral energy is given below. Relation between tetrahedral energy and octahedral energy is given below. The relation is on the board, people. वो ड्रॉ भी करना है, बट ड्रॉ लास्ट में सब पॉइंट्स लिखने के बाद करेंगे. आई विल शेयर द पीडीएफ ऑन द ग्रुप, तो आप उससे कॉपी कर सकते हैं. बट कॉपी द एनर्जीज. डेल्टा टी इज 4/9 टाइम्स डेल्टा नॉट. Ligand, number of ligands compared is 4/6, so 2/3, and the field strength is also 2/3, so 2/3 times 2/3. Done. Next point. Since the orbital splitting energy is not sufficiently large, for forced pairing, and hence low spin configurations are rarely observed. Low spin configurations are rarely observed. Next point. Very good. sp3 bracket tetrahedral complexes, sp3 bracket tetrahedral complexes are generally favored for bulky ligands, and for weak field ligands. Whereas DSP2, whereas DSP2, that is square planar complexes for non-bulky and strong field ligands. Non-bulky and strong field ligands. बाकी है मस्त. Good. So we did CFSC in octahedral complexes. इनका coordination number क्या था? 6. And for coordination number, there can be two types of geometries. Which are the two geometries? You can either have SP3 or you can have DSP2. SP3, what is the geometry, people? Tetrahedral. One of them is behind the plane. And what about DSP2, people? What's the geometry? Square planar. Let's try and understand this. Geometry समझाइए. इसका geometry क्या था, people? Tetrahedral. And the geometry over here is remember in sp3d2 or d2sp3, what was the geometry? It was octahedral. So यहाँ पे if you imagine the central metal atom, one of the ligands will come from here, the other here, one above the plane and one. Can you give me the angles over there? What was the LML angle? बराबर. What was the LML angle? LML angle. बोलो.
90.
This LML, what's the angle? LML. 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 So either the angle was or the angle is. And hence when the ligands approach, they have to approach in such a way, because angle क्या बनाना है उन्हें? 90 और along the axis ही आना पड़ता था to form a bond. And hence increase of energy of D x square minus y square and D z square. What is the angle here? 109.5. 109 degrees 28 minutes. याद है? थोड़ा liberty है. To form this, hence they are not approaching along the axis. Totally in between the axis भी approach नहीं, but we say that the approach is in between. You understand why is the difference in DD splitting over here? इसलिए higher energy किसका है? dxy, dyz and dxz, which is which orbital? The lower energy belongs to Eg. Did you people get that? Yes or no? इसका CFSC अगर फॉर्मूला लिखते कैसे लिखते? 0.4 or 2 by 5 delta T into number of electrons in T2G plus number of electrons in EG into minus 0.6, तो minus हो जाएगा. Getting that? Now what about square planar? We have written crystal field splitting in tetrahedral. Crystal field splitting in square planar scope में नहीं है. It is not there in syllabus. But थोड़ा अगर समझना है, यहाँ पे you have to have, जैसे लिखा, क्या लिखा है वहाँ पे, tetrahedral complexes are formed for bulky ligands. देखो यार, non bulky ligands for bulky. Because the thing is, if you have bulky ligands, you cannot have bulky ligand यहाँ पे and यहाँ पे. The reason is they'll start repelling each other because the angle available is only. The moment you form bulky ligands, वो यहाँ पे बहुत repulsion ज़्यादा होता है. They are not stable in square planar, and that is why they move to tetrahedral. थोड़ा सा एक्स्ट्रा जिनको समझ में आ रहा है. इफ यू वांट टू राइट ऑल दैट थोड़ा एक्स्ट्रा तो मेरे को बाद में मिलना. आई विल गिव यू ऑल द डिटेल्स. बट स्क्वायर प्लेनार के लिए पूछने नहीं वाले. बट दोज हु वांट टू अंडरस्टैंड, स्क्वायर प्लेनार इज ऑक्टाहेड्रल विदाउट द z एक्सिस वाला पार्ट. इफ यू रिमूव द z एक्सिस वाला पार्ट, z एक्सिस हटा दो तो वो स्क्वायर प्लेनार है. एंड इफ यू वांट टू थोड़ा सा अंडरस्टैंड मोर, dz स्क्वायर है ही नहीं. So the orbital with the lowest energy here is dz square. In octahedral, Eg का energy सबसे ज़्यादा था, and Eg was dz square and d x square minus y square, and here it was T2G. T2G में कौन कौन थे? dxy, dyz and dxz. Tetrahedral उल्टा. Who has higher energy? Who has lower? Eg. Square planar में the lowest energy belongs to dz square. dz square का involvement ही नहीं है ज्योमेट्री बनाने में. Not in scope, but थोड़ा सा extra. समझे इधर तक? Yes or no? If you want to know crystal field splitting energy in square planar complexes, join JP's Academy. और online वालों को बाकी can come and meet me office में. हाँ कोई बोला रहे सर. हाँ पॉज कर दो. क्या है?
Sneak peek. Just versus.
हाँ. Please write down. Rules. Last.
How many?
Last 2 minutes. Last 3 minutes.
We go diagram.
Rules. हाँ. Write down. For coordination number 4. For coordination number 4.
चलो पहले का ये लिया.
अरे पीडीएफ भेजने वाला हूँ ग्रुप पे. भेजना हूँ ग्रुप पे. और coordination number 4, if strong field ligand is present, if SFL is present, pairing takes place. तो SFL दिखा, क्या करने का? पेयरिंग करने. ओके. Pay attention here. So we have NiCN4, 2 minus 2 मिनट में हो सकता है जल्दी जल्दी give me the charge on Ni give me the charge on Sino is minus 1 so how much is Ni plus 2 nickel जल्दी जल्दी electronic configuration 3d8 4s2 but we have Ni plus 2 over here so what will the configuration become 3d8 4s0 प्लीज रूल रीड करो क्या लिखा है रूल में इफ strong field ligand is present क्या करेंगे हम pairing takes place why does pairing take place pairing takes place why because CN is a strong field ligand since CN is a strong field ligand 3d8 में pairing करके how will 3d8 look like this is 3d8 उसके बाद कौन आता है 4s and what do we have 4p how many lone pairs do we have to accommodate 4 1 2 3 4 what will you write here electrons from ligands please give me the hybridization and the geometry square planar magnetic moment and diapara inner outer high spin low spin समझा anyone who don't get that बोलो रे instead of CN if I put NiCl4 2 minus nickel is again over here plus 2 minus 1 तो क्या डिफरेंस ऑब्जर्व करेंगे हम स्ट्रॉन्ग फील्ड लिगेंड पेयरिंग बट ओवर हियर नो पेयरिंग व्हाई Cl is a weak field ligand so this will remain as it is 4s पे कौन आएगा how many electrons how many lone pairs do we have to accommodate 1 2 3 4 क्या लिखेंगे हम electrons from ligand hybridization geometry number of unpaired magnetic moment diapara high spin low spin inner outer that is tetrahedral complexes any questions over here Someone said that.
Yeah.
Okay. So people, this is to be done as homework. ठीक है. बाकी if you have any doubts, phone number तो है वीडियो पे. ठीक है. That goes without saying. चलो. Thank you so much. Tata bye bye. I will see you people next class. That is tomorrow with homework and जो questions मैंने दिया